All right, so let's dive into our last case, complex fractions. So lesson learned on the last one, we might want to check that this actually does give us 0 over 0. If I plug in 1, I get 1 half minus 1 half over 1 minus 1, so 0 over 0. I have to deal with the complex fraction. Two ways. One is the way most students will, which is to just start using all of our information and knowledge of rational expressions to follow the order of operations without a better way to say it. We'll combine these two terms in the numerator by just subtracting, the way we have to do for rationals. So they will go ahead and say, okay, well, let's multiply this by 2 over 2, this by x plus 1 over x plus 1. That'll get us things with common denominators. We can actually do the subtraction, and then we'll, I personally, that will sometimes be more efficient, but rarely in these cases. The more efficient way to handle these, and if you want to see me walk through that, I think I did in some of the lecture pieces. I think I put it in some of my examples so that everyone could see both options and sort of which one they like. But my strategy is to multiply by the LCD of all of our fractions within the big fraction. So what that means is if I look at this expression, I've got denominators, two denominators within my bigger fraction, right, within my bigger rational expression. And the least common denominator of those two things is just those two things multiplied together. They have nothing in common. So I would multiply the top, and honestly, it doesn't even matter if it's the least common denominator. It's canceling those common factors from the numerator and denominator. It's pretty simple. So I'm going to multiply by this. And I'm going to do that on both the numerator and denominator so that I'm not changing the expression in my limit notation. Right, I'm multiplying by 1. And then magical things are going to happen as I distribute this in that numerator to those fractions within my fraction. So I can now say we have the limit as x goes to 1. If I distribute that 2x plus 1 to that first fraction, that first term, the x plus 1s will cancel and just a 2 will be left behind. If I distribute it to the second term, the 2's will cancel and just the x plus 1 will be left behind. This is why we've done this. We no longer have fractions. So if you are fraction averse as I am, you've avoided them. And on the bottom, let's go ahead and just leave everything again unmultiplied, right? It's very similar to what we were doing when we were handling those radicals. Our whole goal was to get rid of the ugly part. So make the ugly part pretty and leave the other part alone, because what should happen again is we should be able to cancel out a common factor from the numerator and denominator, that factor of 1 that's there. So let's clean up this numerator. It looks like we have minus x minus 1. So we end up with is equal to the limit as x goes to 1 of negative x plus 1 all over all this. I'll throw the 2 out front because it upsets me in between the 2. And then maybe we recognize, oh, I could have factored a negative 1 out of this. Okay, now these are the same, so I can get rid of my 1. Cool. So I'll take one more step before we plug in and just rewrite this in a simpler form. I'll get a negative 1 all over 2x plus 1. And then we can plug in. So this is negative 1 all over 2 times 2, which is negative 1/4. Perfection. So pause it, try it on the next one, or just follow along. Again, I'm going to use my overall fraction choice. There's only one little fraction within my larger rational expression, and that's that 1 over x plus 2. So there's my common denominator. If I distribute this, yes, okay, I was just verifying really quickly that it did go 0 over 0. I'm only going to deal with distributing this to the numerator because that's where my ugly little fraction was. So here, that's just 1. Here, okay, plus x plus 2. Great. And on the bottom, I'm going to leave this factor. I am not going to distribute And then we can see, I'll go ahead and do it here. 1 plus 2 is just 3. So let's go ahead and do that. Ugh, don't have to deal with the opposite thing. And now I could plug in because I've gotten rid of my problem child. So we have 1 over negative 3 plus 2, which is 1 over negative 1. I added an extra negative. And it showed up so slowly I couldn't even see it happening. So our answer is just negative 1. And remember, in the actual lecture Jamboard, which I will export as a PDF and throw into this OneNote, I included a screenshot from Desmos for every single one of these problems. It's sort of my way of checking my work, but also to show you that there is a relationship between our graph and all of this algebraic work. All right, our very last one of these algebraic analytic limits. Oh my God, I threw up a little in my mouth because it's definitely 0 over 0, but now we've done both our radical and our rationals. I'm going to deal with the fractions first, and then realize I'll probably have to deal with the radicals after. But let's deal with those fractions first, because they're the things that are making me a little more upset. So again, if we look at the fractions within our bigger fraction, there are 2, one with a 2, one with the square root of x. So I'm just going to multiply everything through by 2 root x. All right. Knowing full well I'm going to have to probably pull out a conjugate once I finish. So we get the limit. This x goes to 4 of square root of x's will cancel, we'll get a 2. And the 2's will cancel, we'll get a square root of x. Ooh, actually, you know what? I'm going to save myself a little conjugate work on this one. I'm going to do the clever thing a lot of students did when we handed this on the quizzes. A lot of students recognized that they wanted this, and instead of multiplying by a conjugate to get things to happen, what they did was they broke apart that denominator using the difference of squares, right? They went and said, okay, well, x is the square root of x squared, and 4 is 2 squared. So there's no reason I can't rewrite this as the square root of x plus 2 and the square root of x minus 2. That's the same. That's equivalent, right? So this is the limit still as x goes to 4. I might even, as I'm doing this, go ahead and factor the negative 1 out of this numerator. Think about what's going to be left behind. That'll make my square root of x positive, which is what I need for it to match up, obviously, with what's below. And then it'll make my 2 negative, because it was positive. So there we can see there's our common factor from the numerator and the denominator. Get rid of her. All right. And now we are ready to plug in. Beautiful. So I can go ahead and do my substitution. Negative 1 all over the square root of 4 plus 2 is negative 1 over 4. Done. All right, there we go. That is all of the algebraic limits until we get into the trig stuff, which will come later.